Welcome to CSEGURU. In this session, we will discuss the topic C program to implement the array representation of a queue. Already, we have discussed in the previous session what do you mean by queue, how to represent queue using array, and what are all the operations we can able to perform with array representation of a queue. That is Enqueue operation, insert operation, Dequeue operation is nothing but delete operation, and peek operation. All these operations we have discussed. Now, in this session, we are going to discuss all these three operations, Enqueue operation, Dequeue operation and peek operation. Along with that, we will discuss the display operation also, how to implement using C program with the help of array representation of a queue. So, this is the C code to implement. So, here you need to declare the maximum size of the array. Maximum size of the array here we have declared as 10. So, the array size will vary from 0 to n minus 1, that is 0 to 9 locations, totally 10 memory locations. Then the queue data structure, and initially you need to initialize the front variable as -1 and rear variable as -1. Then these are all the user defined functions we are going to implement for different operation. For Enqueue operation, that is insert, Dequeue operation delete, peek and display operation. And all these operations we have to specify in the menu. Enqueue, Dequeue, peek, display, and final is exit. So first, using the switch statement, you need to enter the option and get the option. And case 1 is nothing but insert operation. That is nothing but Enqueue operation. So once the function is called, in the sense, the control will be transferred to the corresponding user defined function, and here it will perform Enqueue operation. And case 2 is delete operation. So here this is the user defined function that will implement the delete operation, and the deleted value will be stored with the variable val. If value not equal to -1 in the sense, it will display the corresponding value. If it is -1 in the sense, meaning is queue is empty. Okay, and case 3 is peek operation. This peek operation just it will retrieve the front element in the queue. So what is the front element in the queue? That it will retrieve and store with the variable val, and that will be displayed here. And case 4 is display operation. What are all the elements present in the queue array? It will display one by one. So these are all the 4 options we will implement. And fifth option, if you are entering in the sense, that will exit from the switch statement. Okay. And here, Enqueue operation, that is nothing but the insert operations. So what is the number you want to insert? That number you have to enter. For example, if I want to enter 5 in the sense, this element I want to insert. Okay. So here, 3 cases is there. This you consider as case 1, this else if consider as case 2, if consider as case 1, else if consider as case 2, and this else part consider as case 3. Okay. So here, for example, I will take the maximum size of the array here is 5. So here, case 1 if you are considering in the sense, the array size will vary from 0 to n minus 1. Maximum size of the array is 5. And here n minus 1 in the sense 4th memory location. For example, initially all the elements I have placed in the array. Okay. So what is the size you have allocated for the queue array? All the memory locations is filled. Now, okay. So this is case 1. If rear equal to max minus 1. Now rear is pointing to 4th memory location. What is our maximum size of the array? Maximum size is 5. 5 minus 1 in the sense 4. Yes. Rear is pointing to 4th memory location. This condition is true. If this condition is true, it will print overflow. What is the meaning? You have allocated 5 memory location. All the 5 memory locations you have placed the element. And if you want to insert one more element in this, then you need to increment the rear position by 1. If you are incrementing the size you have not allocated, it exceeds the allocated memory. So automatically it will raise error. That is, it will display queue is overflow. Okay, what is the array you have allocated for the queue data structure? It overflows. Okay, whatever the memory locations you have allocated, all the memory location elements are placed. There is no more memory location to insert the new element. So just it will display overflow message and it will exit. Okay, suppose case 2 if you are considering in the sense, same 5 memory locations you have allocated, size will vary from 0 to n minus 1. Okay, and here both front and rear is pointing to -1 position in the sense. Okay, both front and rear is pointing to -1 position in the sense. What is the meaning? you have not inserted any element into the queue. The queue is empty. Whatever the element you want to insert now, that is the first element you are going to insert into the queue data structure. That is the meaning. So in this case, what you have to do it in the sense, you have to set both front and rear to 0th position. Now, this position you have to set both front and rear. This position you have to delete. Just the front variable and the rear variable you are resetting to the 0th position. Okay. And now you have to place this element. 5, you have to place it here. Okay. Now, front and rear both will point to the first memory location in the queue array. Okay. So, this is case 2. This is case 1. Okay. And case 3, if you are considering in the sense, here same array you need to consider. The maximum size is 4 only. Okay. 0 to n minus 1. 0 to 4th memory location. And here I have placed the element 10, 20, 30. Okay. For example, first position is pointing to front and the last position where you have placed the element, that is pointing to rear position. Okay. So here if you are checking rear equal to max minus 1. No, rear is pointing to 2. If it is 4th position only, this condition will be true. Okay. So this condition fails. Next, else if check front equal to minus 1 and rear equal to minus 1. No, this condition is also not true. Front is pointing to 0th memory location, rear is pointing to 2nd memory location. So this condition is also false. It will go to else part and it will increment the rear position by 1. So increment the rear position by 1 and the rear now it will point to 3rd memory location. And what is the number you want to place it? Place it in the queue of rear. 5, I will place it here. Now rear will point to 3rd memory location. So this is case 3. So if it is max minus 1 in the sense, it is overflow. Front and rear both is pointing to minus 1 memory location in the sense, just increment front and rear to 0th memory location and place the element. Okay. Else, just increment the rear position and then place the element. Okay. This is Enqueue operation, that is insert operation in queue array. Next is Dequeue operation, that is nothing but delete operation in the queue array. So here initially you need to declare a variable val and front is equal to minus 1 and front greater than rear. So what is this condition in the sense? For example, here I will consider 5 memory locations only, 0 to n minus 1. Okay. And here front equal to minus 1. Suppose front is pointing to minus 1 memory location or front is greater than rear. Okay, front is pointing to minus 1 memory location in the sense, what is the meaning? It is underflow, there is no elements in the queue. That is the meaning if front is pointing to minus 1 memory location. And what is this condition? Front greater than rear. For example, here I have inserted all the elements in the queue. Okay, and now front is pointing here and rear is pointing to the last memory location. Okay. Suppose if you want to perform delete operation in the sense, how you will perform in the sense, normally just increment the front position by 1. Automatically this element will be deleted. Now front will point to 20. Next, if you want to delete it, increment the memory location by 1. Now front will point to 30. Okay. If you want to delete this one also, just increment the front position by 1. Just now front will point to 3rd memory location. Next also, if you want to delete it in the sense, just increment the front position by 1. Now it is pointing to 50. The last element when you want to delete it, if you increment the front position by 1 in the sense, just delete the element, increment the front position by 1. Now front will point to here. When you are deleting the last memory location, automatically front will be incremented to next memory location. So in this case, rear will point to 4th memory location only, but front will point to 5th memory location, but that memory location is not allocated actually. Okay, just it will be a pointer to that next memory location. That is a front variable. Okay, so in this case, if you are considering front is greater than rear. So meaning is, all the elements you have inserted, but all the elements you have deleted also. Now these memory locations are free only. In this case, whatever the maximum size you have allocated, for the maximum size, all the elements you have placed, but you have deleted. After deleting the last element, front will point to the next memory location, but rear will point to the same memory, last memory location only. Okay, in this case, front is greater than rear. If any of this condition is true, in the sense, it is underflow condition, Q array is empty. That is the meaning. In this case, it will return minus 1. If the Q array is empty, in the sense, it will return minus 1. Okay, else, what is the value you want to delete? For example, here 0 to n minus 1. Okay, and here elements are placed. And now front is pointing to first memory location and rear is pointing to third memory location. That is array of 2. Okay. Now Q of front. What is Q of front here? 10 is Q of front. That will be stored with the variable val. Just to increment the front pointer. Now front will point here. Increment the front point. Automatically element will be deleted. Suppose if any of the case, if front is greater than rear, in the sense, what is the meaning? All the elements in the array is deleted. Now the memory locations are free only. In that case, you can set front and rear to minus 1, reinitializing the pointer to empty memory location. So in this case only, front is greater than rear, in the sense, in this case, you reset to minus 1. After deleting front pointer, after deleting the last element, if front is greater than rear, in the sense, okay, suppose here, here I am deleting the first memory location. Okay, now front will point here, but after deleting the last memory location, front will point to here, the next memory location, right? In this case, suppose if front is greater than rear, in the sense, in that case, front and rear, you reinitialize to minus 1 memory location and then return the deleted element. So this is all about the dequeue operation or delete operation in Q array. Okay, can you able to understand this condition? If you are deleting the last element in the Q array, after deleting, front will point to next memory location. Here front will point, but that is not allocated. Okay, in this case, what you have to do it in the sense, if front is greater than rear, after deleting the last element, if front is greater than rear, front and rear, you reinitialize to minus 1 memory location. Okay, so this is dequeue operation in Q array. Next, peek operation. Just peek operation, what is the front element in the Q array? It will display the front element. Just it will display, nothing it is going to do. Okay, for example, this is front and this is rear, in the sense, here if you are implementing the peek operation, it will check front equal to minus 1 and greater than rear. If the condition is true, in the sense, Q is empty, that is the underflow condition, it will return minus 1. Just you are checking here whether the Q is empty or not. If not empty, in the sense, it will go to else part, just it will return Q of front. What is front here? It will return 10. 10 it will return, and this value will be returned to the main function. It is peek operation. It is just like the peek operation in stack. In stack, it will display the top element of the stack. But here in Q, it will display the front element of the Q. That is the difference here. Okay. And the display operation, if you are considering, in the sense, here also it will check whether the Q is empty or not. That is, front is minus 1 and Q greater than rear, in the sense, Q is empty. So if the Q is empty, in the sense, you cannot able to display the elements. There will not be any elements in the Q. So you cannot able to display. Suppose if this condition is false, in the sense, it will go to else part and using the for loop. For example, here if this is the Q array, in the sense, rear is pointing here and front is pointing here. Okay, the memory locations is 0 to n minus 1. So here what it will happen? I equal to front. I will point to front position. Okay, and I less than or equal to rear up to this position, it will display Q of I. First it will display 10. Next, I value will get incremented to next memory location. Now I is pointing to next memory location. It will display 20. Next, I gets incremented to next memory location. It will display 30. Next, I gets incremented to third memory location. In that case, what it will happen? This condition fails. I less than or equal to rear, condition fails. So it will exit and it will display 10, 20 and 30. These are all the elements present in the Q array. Just it will display the elements present in the Q. So these are all the different operations we can able to perform with the array representation of a Q. Enqueue, dequeue, peek and display operations. Okay. The main operations here, if you are considering in the sense Enqueue, Dequeue and peak. Display operation, whenever you want to check the elements present in the queue, in that case, you will implement a display operation. Thank you for watching this video.